Hello, this is Deanna Kosaraju, founder of Global Tech Women. I want to welcome you to Voices 2.0, 2014. Thank you so much for attending this session, Eventlog, seamlessly integrated graphical debugging tool. And I will let Devi introduce herself and talk to you about her paper. I will be going off screen, but I will be available if you need me. Just call on me, and I will post her paper here in about 20 seconds. So go ahead and take it away.
Okay, thanks, Diana. Happy Women's Day to everyone. So I would like to introduce about myself. So I'm Devi. I have more than 10 years of experience in embedded systems, and all my experience in embedded system domain is around microcontrollers like PIC 8021 and wireless security protocol, wherein like P and WP and all the stuff. And then I work on device drivers, BSPs, HAL, and board bring up stuff like that. Currently, I'm associated or working with HP India. Here, I'm going to present you about a debugging tool that me and my colleague Binod had worked on. So, before I get into how we did it, I would like to give you a background of what triggered us to, start with this tool development. So basically, me and Binod, we work on inkjet printers, and sometime back we had to work on a system defect that involved multi-threads and OS of primitives and frameworks and etc. So this defect is basically it requires system level knowledge, and we had to spend weeks on debugging this issue as we had to understand the system and develop a sequence of events so that we get a full flow of uh, the events, and then we analyze. Uh, we had to analyze the particular issue with respect to the threads and stuffs. So what we had to spend this using, like in one of our debugging techniques we had to use a debugging tool. I believe you are all aware of something called trace. So we had a debugger tool, and that debugger tool is basically is a special tool which helps in capturing the trace and stuff. So the trace means basically it gets into the hardware and captures the instruction level information, so that when suppose we have to capture a sequence of event at a particular timestamp, so enabling this hardware helps us to capture the deeper set of instructions, and in this way we had to capture and debug the issue. And we also had to use different other techniques which would help us to get into the details of the issue. And so when we were doing this, when, for example, when we were doing debugging with respect to the trace, we had got a huge amount of data, and capturing these data and analyzing was a biggest challenge for us, because we had an enormous amount of data, and we weren't looking to that extent, and we wanted a little higher level of data which we couldn't get with any other debugging tool that we had at present. So we had to basically spend most of our time in filtering the data like that, and looking for different debugging options, so that we can really get into the details that we actually wanted. So yeah, then at the end of probably say 3 weeks, we were able to root cause this defect, and we were happy that we could get into the defect and fix it. But we weren't happy on the part that we had to spend large amount of spend large amount of time in debugging and filtering out the debugging information that we had collected. So this triggered us, me and Binod. So we were wondering that definitely this is not a unique defect, and there should be similar defects in different environments. So we were thinking there should be some kind of support that should be available, wherein we can go and get those required details rather than getting enormous or getting a very little of data. So we went ahead and we looked for approaches and different debugging tools that available in the, we did a web googling and we spoke to different people, and we got a different set of data. And one of the data that triggered us, and which we thought would be much more easier to integrate, and which will require less no hardware and all, we actually thought event logging is a good tool which would help us. So with that in our mind, we thought we'll go ahead and probably we'll so first, to start with, we had to look for the debugging environment that anyone is using. So for us, we had to start with GHS, because we work with inkjet printers, and for our debugging, we actually use GHS debugging tools. So with the event logging in our mind, we approached the GHS people, and we also understood, we discussed the problems that we faced, and what is the solution that we are actually proposing to develop a new tool. So basically, GHS people were very supportive, and they said they also can support this tool. So we went ahead with that progress. And then we explored with the OS, operating system becomes another main part, which will involve this, which would need to be a part of this debugging tool development. So we explored on the OS part, and we also figured that there are various OS which supports in a different ways, and even if it doesn't support, probably you can go ahead and tweak your OS calls and make sure that your framework is part of it and your debugging tool can be made up right. So in our case, our operating system was also supportive to enable these plugins and have the tool ready. So this was our basic research, and this was the first step that we had to have for getting into whether we can get into the next step. So now we were ready. We thought that, okay, we have the enough and sufficient information that we can start with for enabling the tool, and so we started looking for the next steps. And now probably I have probably you can look into my document that I've shared here to see what are the steps that basically that we had to go through after this. The first step, so probably you can go to first page, wherein I have listed down the steps to enable the event logging system. So to be very simple, and for a layman, even for a layman to understand how to get into this approach, these were the 4 steps that I would say. So basically, create a data structure to hold the events, and the next step would be to fill this data structure whenever or wherever you want the system routines to capture it, and allocate some memory in the target, whichever target you are debugging with. So in our case, it was printers. So it can be mobiles or any other environment that you guys are working with. And make sure you have enough memory that you can put the data into it. And make sure that there is a GUI tool that should be available for the debugging tool to be displayed graphically. So if you see, basically we call this event logging tool as if you see an acronym, it will be like a picture is worth 1,000 words. So basically we can say it is like a digital video recorder. So at the end of the day, we want whatever debugging data that we capture, it always helps an engineer to look at the data in a graphical format to capture the issues quickly, than to look at the logs and very deeper event systems. It's always easier to go and look through a graphical tool and see and have a quick view of what is happening in the system. So let me start with the first step. So here, create a data structure to hold events. So first thing, before you even want to try how to have this data structure placed, first thing we need to make sure is we have a GUI tool that we have to decide on the GUI tool that we are going to show our debugging event logs. So how are you going to do? First, decide which tool we have to use it. So in our case, we decided that we'll be using a Green Hills supported tool. So Green Hills actually supports multi, and we thought we'll be using a multi tool to enable this event log in a graphical way. So that event log, so this data structure is designed in such a way, in our case, we had designed in such a way that it can be displayed even through the multi GUI. So once you have the necessary details of the data structure, now go ahead and fill this data structure. So how do we fill it? So that depends on your requirement, but it will be always good if you decide to have it for the whole system. So, so basically, if you go to the second page of the document that is being shared, so you can see a picture there where you can see that so there are these blue boxes which says operating system, and the green which says application firmware. So these two talks about about filling up the data structure. So the small flash kind of picture there within each of the blocks like semaphore, mutex, task switch, mempool, task priority, preemption. All this within all of these blocks, we have made sure that we insert this data structure and make sure we fill it at appropriate calls. So these are the basic OS calls. And some operating systems by default support this event log feature, so you may not have to do any changes here. But in case if you are looking for for a new support in the support of event log in the OS, in your OS which doesn't even support it, then you'll have to go ahead and add this event log data structure into those appropriate calls that would help you in debugging. So like, for example, when I say semaphore, when we say a get semaphore or put semaphore, you probably go and add this data structure and fill the required details. And similarly, like for a mempool, when you give a mempool or take a mempool, make sure we fill in the data structure. So anytime this mempools or semaphores or mutex, any of these is being called by the application layer, then all these will be recorded and will be part of your data structure. So this is how the operating system is handled. When we come to application, in my case, I didn't have many applications that I had to capture it for, because the most critical and the most information that we had to take it from was from the interrupt block. And so the way that we had to integrate it is log those interrupts any time an interrupt switching happens, and you have to log the priority and all the other details of the interrupt. And so that was done through the help of this log. So this data structure, there was, in my case, I had to only modify the interrupt block so that it captures all the interrupt related stuffs. So it depends on individual's use case. You can go ahead in application layer if you require that you have to capture a different block, then go ahead and have that framework embedded in them. So this is how the data structure. This is how the data structure is embedded as part of your project. So when I meant the fill this data structure whenever the system require routines are executed, this is what I meant. So now we have a data structure which is compatible with the UI that we are going to use, and we have made that this data structure is filled with the appropriate data that is required for our use case. In my use case, it was like a entire system level use case. Anyone can use it because most of our calls will be system OS calls and interrupt calls. So it has been taken care. And now the next part would be to allocate some memory in the target to store this data. So again, coming back to the picture, if you see there's this orange box which talks about the filters and memories in the build system. So every target that you are going to debug will definitely have a build system. So the next part for us would be to integrate the data that we captured into the build system and make sure that we have a memory allocated in the build system. So this is the only way you can put the data into the into the target, like you can put the data into the target and extract it at whatever point you can take it out. So, so when I say why you need to store it in a memory and take it out, one of the use cases is like, suppose we see an issue. I'm sure you should be facing some issues in client locations or only in the test environment, but not in our development environment. So we had several cases like that, wherein the test team could see this issue, but not the development team. So in those cases, this kind of environment really helps, wherein we can enable this logging system, and once the issue is captured through the test team, all they can do is they can just transfer those memory portion where our event logging is captured, and then give it to the development engineer. From then on, the development engineer can use this log and can take forward for the debugging. So this is one of the ideal use case where you can have a graphical tool which will help you to debug an issue that had occurred in a remote location. So that's the reason you make sure that you have the system with the required memory allocated in the target, and make sure we have filters enabled to it. So suppose when I say filters, what are those? So when you take an example of this OS, let's say when we are debugging, there is a memory asset. So, and I'm very much interested only to look at mempools and not none of the other blocks. So in that case, I should have, my data structure should be designed in such a way that I have filters enabled to make sure that I can only log the data of memory pool. The rest of the data actually becomes redundant for me, because one advantage of this is you have more memory to capture the mempool, and which means that you can capture the data for a longer duration. Obviously, you cannot get hold of a bigger memory pool because of your development system constraints. So enabling this filter is another part, and make sure this enabling filter is dynamic, not static. So it should be runtime, not through the compile time. So in that way, we can enable this, we can advise, probably in the case that I explained earlier, we can advise the test team to, run some debug commands and disable those, or those unwanted blocks, and enable the required blocks. In this way, you have a huge amount of data of the only required details. So in this way, we make sure that the memory and the filters are enabled in the system. Now, the next step and the last step that we have to look at is using a GUI tool. So basically, since we had covered it in the first step, that is creating a data structure which is adaptable to the GUI tool, the last step should be very simple. We have to make sure we use the right GUI tool, and we have to make sure that the GUI tool is able to capture all the filters, and the GUI tool has all the legends that we are describing in the event logging tool, and it has all the ability to zoom in, zoom out, and jump between the tasks of same type, and switch only the required. You can also filter it even using the GUI tool. So GUI tool should also have a filter capability embedded in it. So in this way, the event log can be enabled in any system that is looking for a better debugging. So now that you have a system, a framework that has been enabled, I would like to give a little detail of how we had our system GUI representing the event logs, and probably you can think of a similar approach. So now coming to the second page, under the topic evidence the solution works, you can see that there's a graphical display. So here, if you see the leftmost column, which talks about some like LL, NR, and LNVM2 and all that, these are nothing but the threads that is executed in my system. And so basically, you can also filter out these threads. The GUI should be supporting these kind of thread filtering and event filtering as well. So make sure we have this kind of thread list. And if you see, there are legends to describe what is each of these. So basically, since I couldn't put so much data, I've just highlighted what are these legends. So the red one here talks about the interrupt ending, and meanwhile, if you see the black one in the same black circle in the same display, that talks about interrupt start. So here, if you see, I can capture multiple datas along with interrupt start and end. Suppose my interest is only to look at this interrupt details, like when was a particular interrupt vector initiated and ended. So basically, I can do a filter and just look at the data that I'm interested in. Similarly, you can see the task thread level execution status as well. So I'm sure you'll be interested to know when you're running in a multi-system, multi-threaded environment, you would be definitely interested to know what are the threads running at that point when I have an issue with. So basically you can enable the filters wherein, wherever that, in my case, it was a green line, wherever that green legend is there, probably I can cut my screen in such a way that I only need execution from say X time till Y time, and within that execution I can make sure that I can filter on those required threads only, like basically the threads which were executing between the period X to Y. So this is how you can play with your tool, and in this way it actually gives you a better visibility for you to know how your system level threads are executed, how the interrupts are being handled, and if there is a miss, suppose a semaphore, so you know priority inversion, inheritance, and all those. So you can quickly glance through the portion of the code that you're interested in and see if there was a uh, exceptions in the rule that we have made in the system architecture. So in a, to overall for us, this not only helped us in debugging, it also helped us capture some of these exceptions that were in the system. And the other benefit I can say is basically you can use this kind of tool even for performance analysis. So if you look at the document that I have shared with, so I have talked about in the benefits. So that performance analysis is one of the use case for this GUI. So when you say performance analysis, it's up to the individual to look at what exactly you're looking in performance analysis for the system, and you can tweak your GUI tool to, exactly. Basically, the filters help in these kind of analysis. Use your filters, you do a deeper analysis, and maybe you can. If you see earlier, I had just said like semaphore. I was saying like you can just give information in uh, get and give and take of a semaphore. Probably if you're looking at a much deeper details, you can go ahead and take your data structure and make it, enable to the in-depth that you're looking at. So in this way, you can also use this tool for performance analysis and of course productivity and time. If you remember about my the background that I had to spend around 3 weeks. Of course, if I had a tool like this, probably we could have fixed this issue within a week's time, or probably much lesser. So the other main advantage is the configurability. As I said, you can make it as a dynamic configurable tool wherein the testers or any remote locations can enable this tool and help you capture the data as you require. And this will helpful. This will be helpful if you have it as a dynamic option. So in that way, pretty much more useful for an engineer to focus on the issue that he's or she is looking for rather than having an enormous amount of data. The other main advantage is the cost. So for debugging a complicated issues which involves these system level and thread level details, we always end up using a hardware supported debugger. So wherein we have to spend additional money on the hardware, and of course your board has to be designed in such a way that it enables this kind of hardware debugging through the pins and the clocks that we send in. So in providing this kind of a tool, I believe you will not have all those dependencies, and you can use it at any of the targets that you're looking at. So in my case, I had to look for a particular board which had that hardware pin enabled, and as well I had to look for a debugger which had this kind of trace debugging enabled. So I'm sure this kind of event logging, if it is part of your system, it will definitely help you, in much in the cost. And leveraging is part of, as I said, it can be used as a performance analysis tool, and this should be helping in different ways. So overall, this tool can be used for debugging or understanding the system level architecture, or probably using for performance analysis. And yeah, that will be the major benefits of this tool. So this is all about the tool that we developed for our environment, and it is still helpful for our team, and we got a great benefit out of it. And I'm sure if you try to leverage this concept across your projects, I'm sure it should be helping you a lot. Yep, that's all I have about this tool.
Presentation. Thank you so much for sharing Eventlog with us. And I agree with you. I think that if other people have access to this, it could
Yeah,
save
I'm
them a
done
lot
with
of
my
time and
presentation
energy.
right now.
And we should definitely, can you hear me? Can you hear me?
Hello.
Devi, can you hear me?
Yes, I can.
Okay. I was thanking you very much for the presentation.
Yeah, thank you. Thanks for your time as well.
All right.
See you.
Thanks, everybody.
Bye.
Bye.